welcome back. Today is our review session, and I'm just going to go over how to do these problems on the review sheet with you today. I've tried to adjust the mic, so hopefully the audio will be a little bit better today. So, for the first problem, let's see here. Solve for y. I have y as my base, so I need to raise my number to the negative reciprocal, or the reciprocal, which is negative 2 here. Both sides. On the left, everything will cancel out, so we'll have y equals, and I have a negative exponent. I flip what's inside the parentheses, make my exponent positive. So y equals 9. For number 2, it's just a matter of evaluating. The negative is inside the parentheses, so I don't have to do anything with the number, and I don't have to do anything with the exponent. I simply have to start out by taking the third root of negative 64, and to get that, it would be negative 4 times negative 4 times negative 4. So negative 4 raised to the second power, which is 16. So that's choice A. Number 3, I have f of x equals 3 to the x, then find f of 2, or f of 2 equals. That just simply means I'm going to substitute in 2 for x. So I'll have 3 to the second power, which is 9. So it is choice B. For number 4, I'm going to substitute 8 in everywhere I see x. So I have 8 to the 0 plus 8 to the 2/3 plus 8 to the negative 2/3. And then I'm going to evaluate each individual term. Anything to the 0 is 1. 8 to the 2/3, so I take the cube root of 8, which is 2, and then I square it, so that'll give me 4, plus, I have 8 to the negative 2/3. Well, because it's negative, that simply means I'm just going to put it into the denominator, and since 8 to the 2/3 is 4, 8 to the negative 2/3 is 1/4, and if I add up what I have 5 and 1/4, or 21 over 4. I would accept either answer. If you're using the calculator or graphing calculator and you turn your answer into a fraction, this is the fraction you would get. For number 5, f of x equals x to 1/2 plus x to the negative 2. What is the value of f of 4? Just put in 4 for x. So we have 4 to the 1/2 plus 4 to the negative 2. 4 to the 1/2. The 1/2 power is the square root, so the square root of 4 is 2. Plus 4 to the negative 2 means I write it as 1 over 4 squared. So it's 2 plus 1/16. So we have 2 and 1/16. And 1 there. Or 33 over 16. For number 6, I'm just going to put in 64 for x. Well, it doesn't really matter what happens on the inside, because after I multiply this number, I'm going to raise it to the 0 power. And anything raised to the 0 power is simply 1. Plus 64 to the 2/3. I can take the cube root of 64 first, which is 4, and then 4 to the second power is 16. So I just have 1 plus 16, which is 17. For 27, we have to solve for x. This time, x is in the exponent, so I have to get my bases to match. The only way I can get my bases to match is if I change my base to 3. Remember, we're always going to go smaller. So I have 3 to the third raised to the x plus 2 equals 3 to the second to the 2x minus 1. Now, I have to distribute, so I get 3x plus 6 equals, distribute here, 2x minus 2. Except the rest becomes 2 4. Now I need to get my x's on one side and my numbers on the other, so I'm going to subtract 3x from both sides. So I subtract 3x from both sides, get x, and then if I add 2 to both sides, get 8. So x is equal to 8. Number 8 is the same type of problem. Let's get my bases to match. So my common base has to be 3. So 3 squared to be x squared plus x exponent equals 3 to the 4th. And for this one, I have to distribute my 2, and I will get 2x squared plus 2x equals 4. Make it equal to 0. 2x squared plus 2x minus 4 equals 0. They all have a 2 in common, so you can factor out a 2. So we'll have 2 parentheses, x squared plus x minus 2 equals 0. So 2 parentheses, x plus 2, x minus 1, so x equals negative 2, and x equals 1. Since it said all values, that was kind of a little hint. They probably have more than one answer for x. For number 9, again, same type of problem. We have to get the same bases. So we have 3 to the x equals 3 to the third raised to the 2/3. Well, I multiply my power to power here, so my 3's cancel out, and I will end up with x equals 2. Number 10, again, is the same type of problem. Gotta get my bases to match. So this time I will have 2 to the y minus 3 equals 1/16th. I can get a common base of 2. 16 is 2 to the 4th, so it's in the denominator, it's 2 to the negative 4. So we take our exponents, set them equal to each other. Y minus 3 equals negative 4. I add 3 to both sides. So y is equal to negative 1. I really don't like that. For number 11, it says to solve for the positive value of x. So that means if you were to get a negative value, you would reject it. But in this case, we just need to use the reciprocal power because my base is unknown. My reciprocal power is 3 halves. On the left, they cancel out. So x is equal to 9 and 3 halves. So take the root first. The square root of 9 is 3. And then 3 cubed is 27. So that's page 1. Page 2. Find the product in terms of positive exponents. Well, when I multiply, we add exponents. So a squared times a to the negative 2. 2 plus a negative 2 is a to the 0. B to the negative 3 times b to the first, which isn't an exponent there, remember it's 1. Negative 3 plus 1 is b to the negative 2. And then I have x squared times x to the negative 1, so 2 plus a negative 1 is just 1. Now I need to clean this up. Anything to the 0 power is 1, so the a will go away. The x will stay in the numerator and the b squared will go into the denominator. So it's just x over b squared. For number 13, whenever you have a negative exponent, flip your fraction. I have a. E to the 0 is 1, so you don't have to write that anymore. I will have x squared y cubed, and this is being raised to the first power, so it is choice C. For 14, we're just following our rules of division. When we divide, we subtract exponents. So we'll get c to the 4/5 minus a negative 1/5 minus a negative becomes plus negative 4/5 plus 1/5 is c to the 5/5, which is just c to the first power, c. For number 15, we have a power to a power, so we simply multiply our exponents. We end up with c to the, well, this is you can look at it 2 different ways, but when you get it as 4 over 1, we'll get negative 12 over 2, and negative 12 over 2 is c to the negative 6. Can't leave a negative exponent, so it's 1 over c to the 6. The other way you could have done this problem is you could have divided the 2 and the 4 out, cancel the 2 and the 4, the 2 would have become a 1, the 4 would have become a 2, then you would have 2 times negative 3, which is just negative 6. So you jump right to this step. 16, solve for x. My unknown exponent is in the, or my unknown value is in the exponent, therefore we have to get the bases the same. We'll have 3 to the third raised to the x plus 3 equals 1/3 is 3 to the negative 1 raised to the 2 minus x. So I will end up with 3x plus 9 equals negative 2 plus x. I'm going to subtract x from both sides, so I'll get 2x subtract 9 from both sides, so I get negative 11. And when I divide by 2, and x equals negative 11 halves. Number 17, my unknown is going to be base, so I need to get the base alone. First thing I'm going to do is add to both sides, so I'll get 2x to 5 halves is equal to 64. Then divide both sides by 2, so we will have x to the 5 halves equals 32. Raise to reciprocal power. So x equals the fifth root of 2, 32, sorry, is 2 squared. So x equals 4. For 18, we need to multiply. When we multiply, we add exponents. But in order to add these exponents, we need to have a common denominator. My common denominator is 6. So I need to multiply top and bottom by 3. So we will have e to the 5 6 plus 3 6, which is e to the 8 6, which reduces to e to the 4 thirds. Alright, and my answer is being fast. I did that problem wrong. Wasn't paying attention. So this answer is the correct answer. Make sure you double check if what you have written down. For number 19, I need to simplify. I'm raising negative 2/3 c squared to the third power. So that means I need to raise negative 2/3 to the third power. So negative 2 times negative 2 plus negative 2 is negative 8 over 3 times 3 times 3 is 27. And a power to power. So I have c to the 6. For number 20, we need to solve for x. And in order to solve for x, I need to raise b in negative 2 power. Here will cancel out. So x equals, well, if I have a negative exponent, it just means I write it as 1 over. X equals 1 over 36. Does 16 to the 1/2 equal negative 16 to the 1/2? The answer is no, it does not. This answer is 4. This answer is negative 4. Be careful, remember this is negative 1 times 16. For number 22, we just need to simplify negative 125 x to the third raised to the 4 thirds. So I need to take negative 125, raise it to the 4 thirds power. So the cube root of negative 125 is negative 5. Okay. I'm going to raise it to the 4th power. And then what's going to happen here is that if 3 over 1 are multiplying, those cancel out. So I have x to the 4th. Negative 5 to the 4th power is going to be 625 x to the 4th. I had to use my parentheses here because the original problem was inside parentheses. And that was a 4, not a 9. For number 23, we need to get our bases the same. So 9 to the x equals, well, 81 can be written as 9 to the second, because it's in the denominator, so 9 to the negative second. So that means that x equals negative 2. '24, we have to get our bases the same again. So 7 to the x squared minus x is equal to 7 squared. But no exponents equal to each other. And it's x squared minus x equals 2. Subtract 2 from both sides, so we have x squared minus x minus 2 equals 0. Factor, we'll have x minus 2 and x plus 1. So x equals 2, x equals negative 1. For 25, they're asking me to graph f of x equals 3 to the x. Here it is. So I'm going to move this down here and show the work down below. F of x equals 3 to the x. If I put negative 2 in, I'll get 1/9. If I put negative 1 in, I'll get 1/3. If I put 0 in, I'll get 1. If I put 1 in, I'll get 3. If I put 2 in, I'll get 9. So negative 2 1/9 is right about here. Negative 2 1/3 is negative 1 1/3 is up there. 0 1 1 3, and then 2 9. And then just connect them with a new curve. And this is f of x equals 3 to x. And since we're looking at this, we have to figure out our domain, which will be equal to all real numbers. And my range is y has to be greater than 0. For the next graph, they ask you to graph, let me see, I ended up with the wrong picture. Yes, I did. And second. Okay. We need to graph y, f of x equals 1/2 raised to the x power. So let's see. Let's change some here so we can see the difference. Notation. So using negative 2, negative 1, 0, 1, and 2. If I put in negative 2, I'll get 4. If I put in negative 1, I'll get 2. If I put in 2, I'll get 1. Or 0, I'll get 1. If I put in 1, I'll get a half. If I put in 2, I'll get a 4. So I'm going to start the graphing. Negative 2, 4. and then negative 1, 2, and 0, 1 right there, and then 1 and a half, and 1 and a fourth, and then the net again, and points the best you can, and this is f of x equals 1 half to 2x. My domain for this one is still all real numbers, so I can put in x, any x value, and then my range is y is greater than 0 again. Because remember, it doesn't actually cross the x-axis, and it doesn't touch it. It'll get really close, but not actually do it. Alright, so for the last two problems here, I'm going to have to extend the page here, and I will read them to you, because I seem to have not put them in the slides. So for number 27, a bank offers certificates of deposit with variable compounding periods. For A, Joe invests $1,000 at 6% per year compounded yearly. Find the value of Joe's investment at the end of each of the first 5 years. Because we're compounding yearly, we have to use the simple interest formula. Okay, our simple interest formula is 178. And A equals a sub 0 times 1 plus r to the t. I'm taking $1,000 and I'm investing it, so that's my starting amount. And I'm going to gain 6% interest. My interest is 0.06, and my time is 5 years. So I have 1,000 times 1.06 to the fifth power. And I do this, and I get 1.3382257.8. I just wrote down everything I saw on the calculator. And when I multiply that by 1,000, I will get $1,338.43. For part B, it says Sue invested, so this is Joe over here, and this is Sue. Sue invested $1,000 at 6% per year, compounded monthly. Find the value of Sue's investment at the end of each of the first 5 years. You know, we have to use compounded interest, so we're talking about the fact that the interest is accruing several times a year. So it's 1 plus r over n to the nt. Still investing $1,000. My interest rate is still 6%. except this time it's going to be compounded monthly, which means it's going to happen 12 times a year. And we're going to do this over 5 years. When I divide 0.6 by 12, I'll get 0.005. And that's raised to 60th power. I'm going to add. And I'm going to raise that to the 60th power first. And when I do that, I get 1.348850153. Again, I just wrote down everything I saw. When I multiply that by 1,000, I'll get $1,348.85. Who had more money at the end of the 5th year? Well, looks like Sue had more money. A sample of a radioactive substance decreases continually at a rate of negative 0.04. If the weight of the sample is now 40 grams, what will its weight be in 7 days? Well, whenever we're talking about decay, that's a continuous action, so we need to use A equals A sub 0 e to the RT. Okay, I'm starting out with 40 grams, that's my initial value. And my rate is negative 0.04. And my time is 7 days. I'm multiplying that. So we'll have 40 e is a negative 0.28. So we just take this and type it into the calculator. And we will get 30.231314966. And we'll round that to the nearest tenth, so it's 30.2 grams. So on your test tomorrow, I would expect you to be able to do problems like we have here. I actually kind of modified number 27. We didn't find the value of Joe's investment at the end of each of the first 5 years. We just found it at the end of the 5th year. And same thing with Sue. We found it at the end of the 5th year, and we saw who would have more money. Okay? And that's all I would expect you to do on the test. Nothing more elaborate than that. Making a graph and answering all the other questions we had. I hope this was helpful to watch me do these problems. Sorry I was not able to be there with you today in class, but if you have any last minute questions, I will answer them before we start class. Alright, good luck and happy studying.